one can be 1. So that's well done. Okay, let's have a look at question 10. Okay, right, first thing to always look for with a combined work question is, as we see here, that we have some answers that we can rule out straight away simply because they're not logical. Machine A can do the job in 3.5 hours. Machine B can do the job in 4 2/3 hours. Clearly, they must be able to do the job together in faster than 3.5 hours. So it can't be C, D, or E, because C, D, or E. Machine B is at least going to be some help, and the question is how much, whether them working together is going to make them very much faster, or an hour and 10 minutes, or a bit faster. But clearly, machine A on its own can do it faster than C, D, or E, so it can't be C, D, or E. So let's have a look at a couple of ways to solve it. Now, the classical way is to remember the formula. The total time taken by both machines together divided by the total time taken by one machine, plus the total time taken by both machines together divided by the time of the other machine equals 1. So in that case, this is going to work out to t over, let's say, 7/2 plus t over 14/3 is going to equal 1. Well, this is quite a pain. We're going to have to multiply by, I think, let's start by multiplying by 6 to get to sort this out. And if we say 6t over 7/2, well, that's going to be the same as 3t over 7. And now if we multiply that by 6, it's going to be 6t over 14/3, which is going to be the same as 2t over 14, or in fact t over 7. Okay, equals 1. So that gives us equals 1, equals 6. Ooh, close one. Because, of course, we multiplied everything by 6. So that gives us 4t over 7 equals 6. And that gives us t, I think we're on the right track here, t, 4t equals 42, and t equals 10.5. Well, that's clearly not the right answer, because, as I said, we should be getting a number that's lower. So I think I've simplified the fractions wrongly, so we'll have to do that again. Now, I mean, this perhaps shows why I don't think this is necessarily, although this is, going to give you the right answer if you do your calculations correctly, I don't think using this formula is necessarily the most efficient way to get there. So if we multiply by 6, then we're going to get 6t. Oh, I see. Okay. If we multiply by 7, then we're going to get 7t times 2/7. That's the same as 7t divided by 7/2, plus 7t times 3/14 equals 7. Now we can simplify that, and that gives us just 2t. And we can simplify that, and that gives us 3t over 2, and that's going to be 7t over 2 equals 7, t equals 14, t equals 2. I see what you did, Thomas. Okay, and that's, yeah. So the correct answer is B, 2 hours. Now let's have a quick look at the question again, and we might see that, there's a certain amount of intuitive sense to it. We don't know, if we can eliminate C, D, and E on the basis that machine A is already faster than C, D, and E, when machine A is working on its own, we can pretty quickly say to ourselves, well, does it make sense that the two machines working together are going to work, well, about 3 times and 4 times faster than they work separately? It makes far more sense for it to be B. So even without doing any calculations, we might be fairly intuitively able to plump for B. Now, of course, we could also take the average and divide by 2. That's, that sort of works. It doesn't give you the exact right answer, but certainly in a question which only has 2 machines, it comes quite close. Okay, let's